We are back to sketching graphs of functions with the help of the first and second derivatives, in particular, the notions of concavity and inflection points. Okay, exercise 2.15. We have this function x cubed plus 7x squared minus 5x. Ang daming pinagagawa sa atin. Let's begin with finding the inflection points. So, kailangan natin dito yung second derivative. But before we can get to the second derivative, we must first obtain the first derivative. Sa paghahanap ng critical number for our second derivative, that is in relation to finding the inflection points, hinahanap natin kailan ba undefined ang second derivative or kailan ba siya equal sa 0. But since our function is a polynomial function, palaging defined ang kanyang second derivative. So hahanapin na lang natin kailan ba nagsisiro ang ating second derivative. It is equal to 0 when x is equal to negative 7 over 3. Our inflection point is a point, which means meron siyang coordinates, x and y coordinates. We already know kung ano yung kanyang x coordinate. It's negative 7 over 3. How do we obtain the y coordinate of the inflection point? So ang gagawin natin, we will evaluate our function when x is equal to negative 7 over 3. Isulat natin ang coordinates ng ating inflection point. We will now go to the part about the concavity of our function. Yung ating critical number for the second derivative, which is negative 7 over 3, divides our real number line into two subintervals. We have the interval from negative 2 and 1/3 to infinity and negative 2 and 1/3 going to negative infinity. So, i-check natin ano ba ang concavity ng function in each of these subintervals. We will perform sign analysis again, but in this case, hindi na natin kailangan na gumawa ng table. Okay, halimbawa, kumuha tayong test number, x is 0. So, our second derivative is 14. It's greater than 0, so that means it is concave upward. Our graph is concave upward in the interval negative 2 and 1/3 to infinity. How about when x is negative 3? Our second derivative is negative 4, which is less than 0, which means that the graph of our function is concave down in the interval negative 2 and 1/3 to negative infinity. So, isulat natin yan ha. This will be our guide in sketching the graph of our function. We shall now go to the part about finding the relative extreme points of our function. So, kailangan natin dito yung critical numbers ng ating first derivative. Our first derivative is 3x squared plus 14x minus 5. In-equate natin siya sa 0. Hinanap natin yung kanyang critical numbers. It's 1/3 and negative 5. Meron tayong dalawang relative extreme points, and these critical numbers, 1/3 and negative 5, are the x-coordinates of those relative extreme points. Next, we will find the y-coordinates of our relative extreme points. Let us now plot these points, okay? So, estimate lang ang gagawin natin dito, ano? Mukhang hindi maganda ito napili kong function na to, no? Kasi ang hirap, kasi mga fractions eh. Next time, when I do the second edition of this book, I will produce something which will give us critical numbers na whole numbers, ano? Para madaling mag-evaluate ng function. We will now use the results of our second derivative test, the part on concavity, to help us sketch the graph of this function. Okay, so in this interval siya ay concave down and in this interval siya ay concave up. So what does that mean? So ibig sabihin, itong relative extreme point na to is a relative maximum. At ito naman ay relative minimum and you have there your inflection point. So sa inflection point, nagbago ang concavity. From negative ang concavity, naging positive ang kanyang concavity. Ang hirap ng exercise na to kasi yung mga critical numbers natin ay mga rational numbers. Ang hirap mag-evaluate ng functions kapag ang ating x's are rational numbers without the help of calculator. But even with calculators, ang hirap gamitin when you have rational numbers. Sa second edition, I will produce exercises wherein whole numbers na lang ang ating mga critical numbers. Sige, good night na.